Now we go to fundamental problem 8.2, right? We have this road, okay, 30 kilogram road AB, right? Okay, it's supported by the wall and of course on the floor as well, right? And then there is an extended applied load P over here to hold this. And this one, it has a weight uniform mass. It is a mass of has a mass of 30 kilogram, right? So then what happens is that you have this 30 kilogram times 9.81 weight at the center, right? And then what else do you have? Okay, you are told that actually this is smooth. So basically what is meant by here is that this one, it has no F. F equals to 0. You have P as in a load, but you don't have the friction force. You have the friction here because it is said that this is smooth, right? But you still have the normal force NB, right? Because you have a support, right? Smooth contact. And then what else you have? You have at A, because it lies on the wall, so you have the vertical one, okay? So the vertical, horizontal one, and A, right? The normal force. And you have friction, okay? Because you are told that this is not smooth, the coefficient of friction is 0.2. So there is a friction force here. Why it is going up, this FA? Because you can imagine this. Due to the weight of this, it will, if it fall down, so it will fall down like this, right? See, this one it moved like this. That's why you have P to oppose, and at point A it will go down. So your FA will go up to resist. Okay, your FA is your friction, right? So the question asks you to find what is this P, the minimum P, to prevent this road AB from sliding, from moving. Okay. Okay, so what you have to do is, because the question asks you to find what is the P to the minimum P to prevent from sliding, right? So what happens is that you have to check this situation on the verge of sliding, when it is about to slide. Okay, in this case, when it's about to slide, your FA is mu S and A. Okay, and please understand this. Don't use this equation, this F equals to mu N all the time. You need to check, okay? Only when you know that actually this and the verge of sliding is about to slide, only then you do that, right? And otherwise, don't use this equation, it's wrong. Okay? In this case, so your FA in terms of NA will be 0.2 NA. Okay, you got your first relation, and then you do free body diagram like this. So you do Fy equals to 0, right? But you have Fy equals to 0, you have minus 30, the weight, right? 0.81 times 9.81, and then you have NB over here, right? And then you have this Fa, which is 0.2 and A going up positive. Okay? Is equals to 0. Okay, so here you can express NB in terms of NA, okay, to be 30 times 9.1, which is 294.3, okay, minus 0.2 and NA. We bring these two to the right hand side of the equation, right? Okay, now you have expressed NB in terms of NA. What else? You have to do Fx equals to 0, right? You have P, okay? In this case, this P is P minimum P, because that's what, when you apply Fa equals to mu S and A, then you are evaluating at when it is about to slide. So this is P min, right? So you have P min to the right positive, and you have what? You have minus NA, which is minus NA. Right, and then you have what else? Equals nothing else than equals to 0. So in this case, your P min, it is an A, isn't it? Okay, and then next, what you have to do is you can do moment. First equation, second equation, the third equation you do moment. In this case, you can do moment about B or A, but let's do about A because you want to find P, right? If you add B, then you will eliminate this P in the equation. So what is the point of doing that? So you do moment, okay? Moment about point A equals to 0, assuming counterclockwise as positive. So you have P min positive times what is the distance? This 3, right? P min times 3. Okay. What else? NB times 4, right? So you have minus NB times 4, isn't it? What else? You have 30 times 9.1, which is the weight, okay? Which is positive 30 times 9.1, the weight. What is the distance? The perpendicular distance, which is 2, isn't it? 2 and 2, because it's in the middle, right? Equals to 0, nothing else. And then from here, you can do your maths, P3, P min, your NB, here in terms of NA, NA is term of P min, so you can do that, okay, minus 4, NB, which is 294.3 minus 0.2, NA, which is P min, isn't it? Plus 30 times 9.1, which is 294.3 times 2 equals to 0. Right now, you only have P min in the equation. You see the thinking process of this? So you solve this, you will get your P min as 155 Newton. Right? So the minimum force to prevent this from sliding, from moving, it is 155 Newton.